Okay, so 4-9 is nothing new. It's just we're going to graph inequalities that are either in vertex form, standard form, or intercept form, okay? So we're graphing everything the same, we're just graphing inequalities now, okay? For the most part, they're gonna be in standard form, okay? So if you have a quadratic inequality in two variables, okay, it can be written one of these 4 ways, of course. Y is less than ax squared plus bx plus c, y is less than or equal to, y is greater than, or y is greater than or equal to ax squared plus bx plus c. So it's going to be in standard form, and you're going to have to graph it, okay? Don't forget, when you graph, you need to graph the parabola, okay? Making the parabola dashed for inequalities with less than or greater than, and making it solid with less than or equal to, or greater than or equal to. So the only thing that's changing is my parabola is not solid anymore, it's solid if it has the equal then sign with it, okay? You also have to test a point inside or outside of the graph, whichever is easiest for you, and you shade if it makes a correct statement on where it's at, and you shade opposite if it doesn't, okay? So that's what we're adding to this portion. Oh, I forgot to go through this. That's what we're adding to this portion of things. This is gonna take way too long. Let's do it this way, watch. Let's graph this, we'll just graph it over here.
Change the thing, like you just circle it around.
So my graph is y is greater than x squared plus 3x minus 4, right? No, x squared, why am I not thinking, okay. So, how do you figure out how you graph this? You have to find a what first? What do you have to find first? The vertex, how do you find the vertex? Opposite of b over 2a, okay, so opposite of b over 2a. Vertex equals, the x of the vertex equals opposite of b over 2a. My b is 3, yes? So negative 3 over 2 times 1, and I get negative 3 seconds, yes? So my x is negative 3 seconds, or negative 1.5. Now, what do you do from that? You plug it back in so that you can solve for what y of your vertex is, correct? Okay, so let's solve the y of the vertex. Somebody do the math for me, let's plug this in. Negative 3 seconds squared plus 3 times negative 3 seconds minus 4. What does that come out to be? Tell me what that comes out to. What do you get when you do that math? What do we get? What do we get? Negative 25 fourths. Okay, so you got negative 25 over 4. Because this becomes 9 over 4, right? This becomes negative 9 over 2. And this becomes negative 4, yes? Okay. So yes, negative 25 fourths. So now I have to graph that, correct? So I have negative 1.5. So this is negative 1.5. What is negative 25 over 4 come out to be? negative 6.25. Sometimes it might be easier to do these with decimals. Does that make sense? So I go over to negative 1.5, and I go down to negative 6.25, 6, something like here. Then what do I have to do from there to finish graphing this? Yeah, the mirror. How do I do the mirror thing? You have to plug in a point, okay? You have to plug in a point, so let's plug in a point. What point do you wanna plug in? Positive one?
Yeah.
How about we plug in a negative one since it's really close to here? Like if this is negative 1.5, you know what I'm saying? If I plug in a negative one, then I can just reflect it easier. So y is greater than negative 1 squared plus 3 times negative 1 minus 4. What's negative 1 squared? 3 and negative 1 is negative 3 and negative 4. Negative 4, negative 3 is negative 7 and 1 is negative 6, right? So negative 1, negative 6. So we're going to go negative 1, negative 6, and we're going to reflect that over. Dotted our solid line. Dotted. So it should look like this, right? Something along these lines. Now, I'm gonna plug 0, 0 in to see if I shade inside or outside, okay? If I plug 0, 0 in, I have 0 is greater than 0 squared plus 3 times 0 minus 4. Is 0 greater than negative 4?
Yes.
Yes. So I shade on the inside. Okay? So I shade on that inside. Does that make sense? Okay, you have done this before, where you're just adding shading to it. It is nothing different. Okay, so now let's look at this. A manila rope used for rappelling down a cliff can safely support a weight in pounds provided that W is less than or equal to 1480 D squared, where D is the rope's diameter in inches. Graph the inequality. How do you graph that? What do you think you need to do to graph that? What do you have to graph that? A B. Do you have a B? What? 0. 0. So you technically have, your B is 0, right? So it would be opposite of 0, so just 0 over 2. 1480. What happens when you have 0 divided by something? It's just 0. So my vertex is technically 0, 0, yes? Now here's the deal. I know that my graph is only going to go on this side. Why do I know my graph is only going to go on that side? Because I can have a negative weight, right? That would be crazy. I don't know anyone that has a negative weight to them. I know people that are really skinny, but I don't know anyone that has a negative weight to them. That would mean, I don't even know if you have a negative weight when you're dead, because your bones are still there, like, you know what I'm saying? Okay, so negative, it can't have that. So what are you gonna do with D? Plug in a number and see if we can solve, right? So if I plug in 1, you get 1480 out, correct? Yes? Okay. And it says, graph the inequality, so if I plug in 1, I get 1480 out. So I just need to make a rough graph, it doesn't matter what it's like. I'm gonna get count by thousands. 1,000, 2,000, 3,000. Okay. Now if I plugged in 1, we know it would fall someplace like here. So my graph is probably going, is it solid or dotted? Solid, right? Okay. So I know it's something like this. Let's just pretend that's right. Okay. It goes something like that. Now I have to shade this graph. Yes? Okay. So how do I decide how to shade this graph? How do you decide how to shade this graph? You pick a point. Okay, let's pick a point here. Let's go 1, 2,000. Let's pick this point right here. Yes? and see if when I plug it into that equation, if I shade on the outside, or well, on the inside technically, or on the outside. So 2,000 would represent my weight, is less than or equal to 1480 times 1 squared. Is 2,000 less than or equal to 1480?
No.
No, so the only things that would make this work is if I shaded it on the outside of this graph. That's how much you would have to plug in. Okay. Next, you have two inequalities, okay? Two inequalities. When you're doing two inequalities, what does that mean? What do you have to do when there's two? Why is it not freezing? Okay, when there's two inequalities, what do you have to do? Yeah, graph both of them, and then the shading that overlaps is like the answer to your problems, yes? Okay, so what do I need to do? Can I graph both of these in the forms they're in currently? Are they both in y equals forms? Okay, so I can go from there. What do I need to find first? Your vertex. Your vertex, yes. So let's find the vertex. I have a green and I have a blue marker. So that should make it easy. The green equation, what's my vertex for my green equation? Y is less than or equal to negative x squared plus 4. My vertex is what? How do I find it?
Opposite of B.
Okay, what is b in this case?
4.
0. So what's my x gonna be of my vertex? 0. And if I plug 0 into this equation, what do you get out? What? 4. So my vertex is 0, 4. I didn't even have to do math with that one. That was easy. Okay. So let's go ahead and graph this first one.
Where you plugging to?
1 second. I plug 0 into here. Okay, so we're gonna graph 0, 4, yes? 0, 4. Now, what do I need to do now to graph?
What?
Plug in what point? What do you wanna plug in? 1. Let's plug in 1. So let's plug in 1 to this equation. If I plug 1 in, I get negative 1 squared plus 4. What's negative 1 squared?
1.
Plus 4 gives me, so my point is 1, 5. So this graph is, that doesn't work. It should face down. We did something wrong. I did something wrong. Oh, I know why. I'm being stupid. The negative is on the outside of here. So then it's negative 1, which gives you 3. So 1, 3. Okay, 1, 3. And then I reflect this point over, yes? Dotted or solid line? Solid. Okay, dotted or solid line. Now we're gonna plug in 0, 0 to this equation to see if we shade on the outside or inside. So 0 is less than or equal to negative 0 squared plus 4. Is 0 less than or equal to 4? Yes. So I shade on the inside. Now, blue equation. Y is greater than x squared minus 2x minus 3. Here, to find the vertex, I do have to do some work. How do I find my vertex? Opposite of, so my b would be 2 then, and then 2 times 1, what's 2 over 2? 1. Then I plug it in. 1 squared minus 2 times 1 minus 3. 1 minus 2 minus 3 gives you what? Negative 5, negative 4. So 1, 4 is my vertex, yes? 1, 4, correct?
Negative 4.
Negative 4. 1, negative 4. So 1, negative 4. 1, 2, 3, 4. Okay, now I'm gonna plug in a 2 because it's next to 1 and just make it easy, next to the vertex. So 2 squared minus 2 times 2 minus 3. 4 minus 4 minus 3 gives you -3. So you get 2, -3, which makes sense because this one should face up. 2, -3. This reflects over here, dotted or solid? Dotted. Okay, I'm going to plug in 0, 0 again, because that's an easy one to plug in. 0 is greater than 0 squared minus 2 times 0 minus 3. So 0 is greater than -3, true or false?
True. Oh, fuck.
It's true. It's greater
Oh,
than,
it's true.
so I shade on the inside, and there's my overlap. Okay, we'll stop there for today, and we'll do a couple more examples tomorrow, okay? But this is what your homework is over. Like I said, nothing new, just shading